Okay, so the 204X are bypassable 201X. 2043 is a bypassable 2013. 2042 is a bypassable. The 2040 is a bypassable 2010. Right. So they pretty much do everything their cousins do with a bypass feature, with some caveats. When you put the bypass function in, you give a few things away. They're harder to match way broadband. It's understandable. And when you bring them down, way down low in frequency, you see an IP3 degradation in bypass mode, which is you can contend with it, because if you think about it, when it's in bypass mode, your gain is low, so your input IP3 gets pushed up, right? So if your output IP3 degrades, it begins to degrade when you go below 200 megahertz, slightly at 150, worse at 100, worse at 70 or 80. The limit is 45. I took one down to 45 megahertz the other day. Output IP3 degrades. If the gain was there, input IP3 would degrade unacceptably, but because in bypass mode the gain is closed up, input IP3 gets pushed up, and I can just show it to the customer. In most cases, they can accommodate it. So they're just like their non-bypass cousins with a IP3 degradation at low frequency, and they're a little bit harder to match broadband. But that's the summary. I just looked at the GRF204X switching time, about 150 nanoseconds on, and about less than 50 nanoseconds off. So that'll accommodate most systems.
Any of you guys call me Francis, and I'll kill you.
Oh, bypass mode. All of our bypass mode devices. In my mind, it's overkill on power handling, because the compression point in bypass mode is, what happens is you approach the compression point and then you fall off a cliff. And you know what? It's higher than the gain mode compression point. The bypass mode compression point is higher than the gain mode compression point. So it's going to be, I'll typically see with one of these guys, input P1 dB of 25 dBm, where the gain mode compression point is like 22, 23. So they have high bypass mode compression points, which I guess is applicable, but it's certainly a strength. Bypass loss typically, ideally, in the best place would be 1.5 to 2.5 dB. Sometimes when you do a broadband match, you'll see 3 dB on the edges. Absolute worst case on a difficult match, 4 to 5 dB on the edges, one or the other edges. So, you know, and customers don't balk. They can usually accommodate it, because you're getting your whole objective is to handle a higher signal level, and a little bit more loss usually isn't a problem. Matching broadband, usually there's some limitations, and going way high in frequency, there's limitations. In other words, if the 2013 goes out to 6 gig and hangs on to all of its specs except the gain, you'll have 14 dB of gain out there, and you pretty much maintain all your other specs, IP3, P1, noise figure degrades because of your eval board, your board loss. But the bypass mode devices, they fade away at lower frequencies, so they have a lower max frequency than the non-bypass mode. You got it, you don't get something for nothing, so you give something away. That's what it is. Performance over temperature is similar. The other thing one other thing you got to worry about when you match any bypass LNA. You go into ADS, you simulate the match in gain mode, then you cross your fingers and you look at the bypass mode, because sometimes usually it looks pretty good, but sometimes the bypass mode match is degraded. Then you got to play games between the two to get a compromise. So that might be the only challenge. But in their standard bands, they're fine.
Thank you so much for watching. If you'd like more information, please email us at sales@gorilla-rf.com. And don't forget to subscribe to our channel for more content from Gorilla RF.